Hi everyone and welcome to AWS Julie. For today's video, we're continuing with our new series on needed AWS fundamentals to ensure you pass your AWS certification exams. For this lesson, I want to do a high-level overview of DNS, and in the next lesson, we will dive deeper into Amazon Route 53. Amazon Route 53 is AWS's managed domain name system product. It helps us with two things. First, we can register a domain, and second, Route 53 can host zones on managed name servers. Route 53 is a global service with one single database that is replicated between regions. So it is a globally resilient service and can tolerate the failure of one or more regions and continue to operate. Let's step back and cover the fundamentals of DNS. DNS is a service that discovers and finds other systems on the internet. It translates addresses from the language that computers understand to the language that humans understand and then back again. So if we want to go to Amazon.com, we type in Amazon.com, but computers use IP addresses. So DNS translates our words into IP addresses and then finds that location. It then sends that location back to us and translates the IP address back to words that we can understand. Let's read this domain, www.amazon.com. So we start at the right-hand side, which is the dot, which is the root. The top level domain is .com. The subdomain is Amazon, and then www is the host. The host is not always needed. For example, you could just have Amazon.com without the host part of www. Let's talk about DNS terms that we need to know and understand. First is the DNS zone, which is like a database. The zone for Amazon is Amazon.com, and inside this zone are DNS records such as www.amazon.com. The zone is stored on a disk somewhere, and that is called the zone file. So somewhere there is an Amazon.com zone file containing the Amazon.com zone and all of its records. A DNS name server is a DNS server that hosts one or more zones and stores one or more zone files. And the name servers for Amazon.com zone can answer queries on what the IP address is for www.amazon.com. Next, let's talk about authoritative. Authoritative means that it is the trusted record for the domain. There are one or more name servers that can give authoritative responses for www.amazon.com. Non-authoritative or cached are copies of records or zones stored somewhere else to make that response faster. Root servers are the authoritative for the root zones, and then it continues downstream. Root servers only have the root zone. Example of zones are .com, which is a zone, Amazon.com is a zone, and so on. These zones are how DNS distributes information, and each zone only knows the part that is relevant to them. Let's move on and talk about the DNS architecture. DNS starts with the DNS root. It is where queries start at the root of DNS. And this is a zone just like we just mentioned. But this DNS root zone is important because it is the point that every DNS client knows and trusts. This DNS root zone is hosted on DNS name servers. The DNS root zone runs on the DNS root servers. There are 13 root server IP addresses which host the root zone, and these IP addresses are distributed around the world. And the hardware is managed by independent organizations. There is the University of Maryland, VeriSign, and the Internet Corporation for Assigned Names and Numbers, or ICANN. And these operate and manage the hardware for the 13 DNS root server IP addresses which host the root zone. The root zone is a database and it is managed by the Internet Assigned Numbers Authority, or IANA. And IANA manages the contents of the root zone. So there is a difference between management of the root zone and management of the root servers that host the root zone. The root zone contains information on the top level domains of DNS, and this is controlled by the Internet Assigned Numbers Authority, which again is IANA. It is a root zone database that stores all available top level domains. And this top level database contains top level domains, or TLDs, which are generic. Top level domains such as .com, .org, .edu, and country-based top-level domains such as .uk and more. All of these top-level names must be unique, so there has to be a way to organize all of the domain names. This is where the domain registrar comes in, and the domain registrar is the authority that can assign domain names directly. IANA manages the delegation of these top-level domains to other organizations, and this is known as registries. The root zone simply points to the top-level domain registries. An example is that the root zone is an entry for .com, and that points to the name servers that belong to the registry that manages the .com domain. For example, IANA delegates management of the .com top-level domains to VeriSign. VeriSign is the .com registry. And since the root zone points to the top-level domain zones, it establishes a chain of trust and makes it authoritative. The root zone for the .com name servers will have records for the .com queries. The .com top-level domain contains some records for Amazon.com, but the top-level domain only contains high-level information for Amazon.com, not information about www.amazon.com. These top-level domain records point to the name server that hosts the Amazon.com zone, that hosts the zone file that stores the data for this zone. And then this zone has records for Amazon.com. For example, www.amazon.com points to a set of IP addresses. So long story short, each layer of DNS from the root, top-level domains, and then the domain name servers store a small part of the DNS database. The root zone knows the servers for the .com zone. The .com zone knows which name servers are for Amazon.com, and the Amazon.com zone contains records and can respond to queries. Let's walk through a DNS query. We are trying to reach Amazon.com. So we have the DNS name, but we need an IP address to connect to Amazon.com. So we know that there is a DNS zone somewhere out in the world for Amazon.com that has the answer or response to our query for the IP address to be able to access Amazon.com. Remember, we just talked about this. The DNS zone for Amazon.com has the records that link www.amazon.com with one or more IP addresses. And DNS helps us locate the specific zone needed that provides us with an authoritative response. So when we type in www.amazon.com, what happens? Well, the first thing that is checked will be the local DNS cache and host file on your local machine. So what is a host file? Well, it is a static map of names to IP addresses and overrides DNS. Your laptop might have a local DNS cache, so that is checked first before moving on with the query. So if your local client is not aware, we move on to use the DNS resolver. A resolver is a piece of software on your laptop, tablet, phone, or even a server. It runs on a home router or internet provider, and its job is to take your query for a given DNS name and find the associated IP address using DNS. The resolver is a type of a DNS server and your initial entry point into DNS. The resolver also has a local cache to help speed up DNS queries. So if there is a cache on the resolver, then it might be able to return a non-authoritative response. So a quick fundamental check. What is a non-authoritative response? Well, remember the only authoritative responses come from the ones that are pointed at for a given domain from the top level zone for that domain. So let's say there is no cached entry on our resolver. So the resolver then queries the root zone using one of the root servers. Remember from earlier, all of these DNS servers will have IP addresses hard-coded, and the list of these IP addresses is maintained by the operating system vendor. And the DNS root will not be able to answer our query because it is not aware of www.amazon.com, but it does contain name server records for .com. So for this name server, for the DNS root, it points at the name servers for the .com top-level domain. And then this .com zone will contain entries for Amazon.com. These .com name servers still cannot answer our query, but the information about the .com name servers are returned to the resolver. Now the resolver queries the Amazon.com name servers for www.amazon.com. Remember, this is authoritative because these name servers host the zone and the zone file for this domain and can finally return a response back to the resolver. The resolver will cache the result to improve performance for future queries and then sends the IP address back to us. Understanding this process and why DNS works as it does will really help you in your job interviews and also in the real world. It is important to understand that no one name server has all of the information. As we just saw, every query will send your query to the next step. The root zone gives you the .com zone name servers. The .com zone name servers give you the Amazon.com zone name servers, and then the Amazon.com zone name servers give you the response to your query. And this is all trusted and all authoritative. If you found this content useful, a like and a subscribe would mean a lot to me. It really helps me know what y'all like and gives me an indicator that I am building useful content. Now in our next lesson, we're going to cover another core AWS service, and that is Amazon Route 53. We'll talk a little bit about what we learned in this lesson and go a little bit deeper. Thanks so much for watching.